Good morning. It's not morning. I am joking. Probably about 4 o'clock. What's weird about today is it's not snowing. I don't understand it. I'm kind of suspicious. I don't know whether I want to do a video about this or not. But I'm thinking, why not go ahead and record it? So let me just show you what I am up to here. And if you've seen my driving channel, you've heard me talk about buying brass up so that I can have casting brass. That's about 50 pounds. That's about another 50 pounds. I do have some pretty monstrous brass. I have some stuff I've had before. I also have another 50 pounds right there. And I probably have 20 more pounds showing up today. So, or maybe a little bit less. So anyway, I'm serious about the brass thing. So this is a steam generator. Well, this is a thing that if I can make it work, I'm calling a steam generator. That was pretty cool. This is my original burner that I was using for my steam generator. It is no longer part of the equation, but it's so cute I can't bring myself to get rid of it. This is my inlet and my outlet of my steam generator. And just so you know, a steam generator is a gadget that, unlike a boiler, it makes steam. It's a lot like I guess you could characterize an instant water heater versus a tank water heater. That's really a good example of a steam generator. So don't laugh at this. This is really hard stuff to bend, so it looks like hell. But this is basically the boiler. The idea is to heat these coils up and make steam immediately. And I can pressurize this coil well. I mean, I bent the hell out of it, so I probably have weakened it some. This is stainless, so it's a little bit hard to bend. And this was the very first attempt. I just wanted to see how the stuff actually bent. I didn't even have a bender when I built this one. So when I built this one, I did have a bender. It's not a good bender, but I'm working it out. Anyway, a steam generator will instantly make steam into water. Steam into water. Okay, a steam generator will instantly generate steam from water. Let me try that. And that's what this thing is meant to do. The way that I've got this one set up right now, I have a column, like it's like an intake. I run propane in here, but this is meant to be ran on damn near anything. But so I run propane into here, and I actually have somewhat of a circular, like it comes up and it goes counterclockwise, and then it vents out of the bottom here. Just a real rough prototype. I'm using ceramic wool insulation to cover everything up, but it's basically there's the working part of it, and I'm just playing with it. This was all done with just some little pieces of sheet metal that I had laying around. I do like the concept, and I will probably let's do it this way. We'll probably build a better version. But this little guy is it's going to be a water pump. It's very basic, and it's not really what I want as a water pump, but look how big the thing is. The thing is probably a foot tall, and it's just kind of ridiculously complicated. It's just a bunch of fittings. And actually what this is, use my wand here. This is a, which one is it? Let me make sure I'm pointing at the right one. Okay, there we go. This is a check valve, this bottom valve. And this is a check valve. The way that this works is when I close all this stuff off, just for the time being, and I pull suction on this pipe, this check valve will open up. The little ball bearing will raise up in it and will allow water to come into this area. When I compress this, when I push it back, that ball bearing gets shut down and this ball bearing now gets pushed off its seat. So when I'm pulling it, that ball bearing up here is sucked down and creates a vacuum here, so they can only pull from the bottom. And that basically I'm turning this into a one-way, well, into a pump. That's really what it is. And I'm just using 2 check valves, and I'm going to build a little piston for this. So that I've got to get that done. I have to have this thing working so that I can pressurize this little system. I can't even test the thing. That's why this is just like a big test piece. It'll look a lot different when I'm done. This is a little pressure release. It's an adjustable pressure release. We'll see how it works. But I wanted to put one on here so that I could set that up. I'll probably also have I'll dig around in my valves and I'll find a needle, a valve that I can close relatively tightly, because I need to run pressure through the system, but I need to keep pressure in the system as I run pressure through it, while at the same time having a maximum pressure, like a bleed off in case the pressure gets too high, which when I start shutting all these tubes down, that'll happen. I know I'm going way too fast. Well, for me, I'm going way too fast. Maybe not for you guys. Anyway, what I'm doing today is I'm building this pump, and I need to make a piston and an assembly that will allow me to use, I believe I'm going to use this little gear motor to run this pump. It doesn't need to pump much, so I should be able to, that's a slow speed gear motor, I should be able to repurpose it, take it off my little turntable. I don't even remember what I built that for, but you can see it's a little turntable that for some reason, I do not remember what the heck. Oh well, that's not unusual. I have, I go through all kinds of crazy stuff, and then I'll build something and it works for a week and then I forget it. Anyway, that's what I'm doing. So I need to drill this pipe out and make a piston and make an assembly that I can hold onto here so that I can attach the pump somehow. All right, so I'm back. I found the proper drill bit. The closest I could come was a 25/64. So that's what we got. All right, so that's pretty good. Oh yeah, that looks good. And if it weren't for this camera, batteries dying on me, I would never have any issues with this camera at all. So it died on me again. I think I was in the middle of building that. And basically I just got a 9/16 hole. If I could have made it a little bit better had I had a, well, what would it have been? Like a 17/32. I don't know. Something like that. But anyway, I was able to hit that with a hammer and kind of bend it tighter, and so it's grabbed around that. It's not square. That's really funny. But I noticed the pipe isn't square either, so I'm not all that concerned about it because I can still make it work. And this is, again, I'm just making this so that I have something that I can use for my, so that I can set up a steam generator. But I've got to have this because I'm stuck without it. So whether it's going to be in this form, I'm not sure. I don't really have to do that. I could really, well, we'll just see how it's going to go. This is my old mount. Just a little piece of steel, little tacked in spring loaded gadget. This was a piece of cast. You can see that was way overheated. In fact, that reminds me, someone left a comment. It was kind of a ridiculous comment. And they were like, dude, I can't believe you could do whatever you did on, this is my Old Town channel, and they were talking about some aluminum casting I did, and they had incorrectly identified 750 degrees Celsius. They thought that was Fahrenheit, and they were like, dude, how did you even melt that? And why don't you use flux? And man, it's just such a weird, bizarre, I don't get it. And it was kind of condescending, the comment, not terribly, but a little bit. And I replied with a bunch of with a bunch of points, not being mean, But I did, when I got done, I said, and, you know, by the way, I do forgive you, because I'm happy that people are out there casting, because this guy was out there casting aluminum. So he was, anyway, whatever. But I look at this piece of aluminum and I remember I did this before I really understood that you got to be really careful with your casting. Let's see if I can show that to you so that you can see what I'm talking about. Oops. Not only is the camera maybe not in focus. Yeah, see, that is what happens when you pour aluminum that is too hot. You'll get bubbles in it like that. It actually feels lighter, but you know, it's light anyway, but it does feel really light. So, but if you cast it, he actually was degassing his aluminum, which is a weird thing to do if you don't have issues with it, because you don't have to degas aluminum. That doesn't make any sense unless you've overheated it, and then you have to, you know, it's yeah. Anyway, okay, what? Look at that. It's probably 40 degrees outside. We have some good sun. So I just finished shoveling. We have about like an inch, maybe inch and a half, not much. So the sun's going to melt it quite quickly. So I'm really happy about that. Okay, so I'll get back with you when I figure this out. So I've been dinking around with this, and actually my friends came by, and I went and had a lunch. So we're now in the afternoon, and it is melting out there. I like that. So here's where I'm at. I decided to notch this little piece and then drill a hole through it. The reason I notched it is because that will hold this, it holds it somewhat stationary, right? That little notch in there, it fits relatively close. So, okay, I'm going to dig around and find something to make a wheel of some kind with, yeah, a pulley. Something we don't really need that. We need something better. All right, I'll keep checking in. Okay. All right. All right, I think I've got to do some handwork on this thing to make it work. So I need to file a flat on it. So I'll go do that. Right, so I've got this. This looks all cockeyed and crooked, but it's actually not too bad at all. Just used a little piece of aluminum for a wheel, and I've lined that up reasonably close to the hole. I think we're pretty good. I can adjust it however I need to, with shims or bending or whatever. But what I've got is that. So it looks to me about a 3/4 of an inch. Yeah, about 3/4 of an inch, which is huge. So I ought to be able to, you know, drop it down to something like that, or even less, you know. And the torque is pretty massive, so that's pretty cool. Yeah, that's 3 watts worth of power, 27.8. Anyway, yeah, so that's kind of what I'm looking for. Like that, what am we running here? 2.8 volts. Yeah, I can stop it at about 2.8 volts. But I can't stop it there, about 4 volts. Seems like 4 volts is, yeah, that's a lot of power. A huge amount of torque, Came down, and I've actually cut a little bit of that off too. I made a smaller area. That is an 832 screw. So I measured the outer diameter of a screw, an 832 screw, and then I cut this down to that diameter. Then I threaded it, and because I wanted my bolt to go right up to the shoulder, I turned it over in the tap. Once I threaded it from the wide side, because taps are angled, of a bigger side and a smaller side, I cut it with the bigger side. I mean, how you would typically do, typically tap. Then I turned it over and I tapped it from the small side in to cut it so that I could get the nuts to go right up against the edge of that. So that's kind of what I want. But now I've got to decide how big I want my piece of Teflon. So the nuts will hold a washer, and they'll hold the Teflon in place. That's the idea. I don't think that I need 2 of them, but I like the idea of a lock nut. So anyway, that's where I'm at. And this camera keeps dying, so I'm just going to go cut it and then show you what I've done. Obviously, cutting is cutting, tapping is tapping. I mean, yeah, and I am like blurring this right out, aren't I? Yeah, blurring it right out, of course. So I'll always keep updating you on it. I made that shoulder about 7/30 seconds, and then I found, it was actually a little bit bigger than 7/30 seconds. Then I found a drill bit that was a bit smaller than that, and I drilled through my piece of Teflon. Then I pressed the piece of Teflon onto the shaft. So that's where I'm at now. Then you can see it's just roughly done. I sanded it down a little bit on my belt sander. Now I'm going to put it on the lathe and go ahead and try to make this finish properly. So that's my next step. Okay, so I've taken my little piston apart. There's my actual piston portion, and then here's the structure. And you can see there's my shoulder that I wasn't able to film because of this damn battery and whatever. So I've drilled a hole here, and I just basically eyeball it to try to get it in the center. Well, I did a little more than that, but I stacked up some wood underneath it so that I'd have a level drilling surface. So now I'll find a tap, drill it that fits closely into that, and I'll drill that with a tap drill. That way I can come back through and tap one side of it so that it will focus it. Yeah. I'll drill that with a 29. You focusing? Dude. Yeah, I guess you can see it, whether it focuses or not. Maybe it will focus on the table here. Alright, that's not terrible. Anyway, so that's what I've got. Now I'm going to take my grinder and I'm going to make a cut by hand and just cut a divot in between those two. Well, I'm going to turn it into a U shape. So I put this back in a drill vise and just sat it in vertically, and then by eyeball just cut out a slot in the top of this little piece. So it's becoming a thing. I'm going to take it in, take some jeweler's tools to it and clean it up just a little bit more. So there's my little piston. Yeah, there we go. So I've put an 832 screw in there, which would be like a big 3mm, roughly a 3mm screw, I guess. So I used some 400 grit, and I shined the, oh, let me try that again, that might work really nice. Okay, I shined up, actually I honed the interior of that pipe with the sandpaper, a little bit of oil, a little bit of this, I think this is Bow Shield. Yeah. I use that for the lubrication, and an actual, it looks like an actual hone in here. Let's see if we can, so there's oil in it too. But it had some imperfections in it, some scratches, and it was a little bit rough still. So I assumed that I either needed to get a reamer and completely start over again and ream it out to a standard size. However, it was easy enough just to machine a little dowel and cut a slot in it so that I could get inside there and ream and hone it and clean up the bore. I have welded a couple of cutoffs, bolts or whatever, just what I've laying around. I got a box or a little jar that I use to a nail. What I got here, that's what that is. So they're probably about a 7/16 diameter cut, and that nail's probably 2 millimeters. But anyway, so I'll finish up and turn that into my crank, my connecting rod. Anyway, try it. All right, so I punched the apparent center of these guys and drilled those, just so you know how small that is. There's my hand. So yeah, let me back it up. Yeah, there we go. All right, anyway, I'll continue on shaping this thing. Okay, so I've got this guy going. I'm running it at about 5 volts, pulling a couple watts, so not too much. I used a nail, made a little, I think I may have filmed that. So I actually put an O-ring on the end of that piece of Teflon. I wasn't getting a good seal, so I went ahead and cut a little notch and stuck an O-ring on it. But then I changed the plumbing, just simplified it a little bit. That was no good. I mean, the check valves are absolutely pieces of shit. $10 is what that cost me for each one of these little check valves, and they're not worth a crap. They're not doing anything that they should do at all, so I'm going to have to build my own, I guess. So I've got this running properly, finally. You'd think something this simple would be easy to build, but I had to rebuild my check valves. I bought them for $10 each, and they were just junk. They wouldn't hold pressure. There was a nylon cage and a rubber O-ring and a spring, all kinds of junk in there that really weren't doing anyone any good. Now maybe they would hold under high pressure, but this thing runs so slow that it doesn't really develop high pressure right away. So, yeah. But anyway, let's see if I can let you take a look at the gigantic syringe. So it's slowly creeping its way. And I am working it at, working it pretty lightly. I was thinking about putting a little bearing, well, I guess I could, drilling it and putting a little bearing right here that would, in case this thing is trying to sway, be pushed back. Oh, look at that. I may have a leak right there. I don't know how tightly I put that on. But yeah, that was probably that leak right there. Okay. Otherwise, I think I'm in pretty good shape. I will want to do another T on here so that I can run a pressure gauge off this and see what kind of pressure I'm developing when I'm actually using the thing. Because I'll probably be running it down. You know, it might be as low as that. It might be running at about 4 volts. So And so because I think I'll be running it slowly, it really does have to have good compression. I can't have any leaks anywhere because a piston running that slow has got to be tight fitting, you know. And if I have any leaks at all in here anywhere, the slowness of that what are the RPMs, revolutions per hour, maybe RPHs, will make an issue. I mean, it will be an issue because it will be able to bleed off. So that's one of the things. If you're running something fast, the compression has less time to bleed off. But I've got good compression here. Let me do my finger pressure thing again. Oh yeah, I felt that. Just blowing by. Oh yeah, I'm feeling that. So that's good. It's doing what it should be doing. Oh, I get it. Yeah, there's a drip right there. So when I put back pressure on this, it's pressurizing, it's leaking through. That's actually really good to see. I want to see this thing be really tight. And everything is really tight. The compression's really good on that little pump. And I'm quite happy with the whole thing. That just needs to be tightened. But like I said, I'll put another T-fitting on there and a pressure gauge. So anyway, that's it. Let me go through all the parts here. Obviously the motor, my little drive, call it a pulley, I suppose. This will be the axle for that, and I think it's a 1032 screw I should be pointing at it. This little thing is just a keeper. I just made it out of some scrap I had laying around. Flipped it over and then just fit it in there. You know, it's basically just in place of an actual real key. It's basically a key that sits up against the flat of the motor. And then my little connecting rod, I cut two pieces of some scrap and welded them onto a nail, the end of a nail, and then I grinded to suit. The piston has got a Teflon head, but I cut into the Teflon a slot for the O-ring. So there's an O-ring riding on the Teflon, and I kind of like that idea because I think that will actually help the O-ring. Well, I think it will keep it from being overly damaged. Maybe I'm wrong about that. Then I have my inlet pipe fitting. I have a one-way valve here, and it's basically now it's just a ball in a seat. And what I did was I took all the internals out of this thing, so there's just a stainless or a ball bearing inside of this thing that's sitting on top, and the same thing here. And I drilled through the very top of the fitting a little hole, and I put a wire across it, so that way that ball, if I turn this thing over, that ball can't roll around in here and end up with these balls just somewhere in the system where they shouldn't be. So they're contained, but they're quite loose. Which is what I wanted. So my pressure release, which, you know, and I may change the configuration of all of this stuff, but I think I finally have one part of the parts that I need to make this work. So that's a good start. And I did shave. All right, so I'm done for the day. Or, no. Let's see. Yeah, I think I'm done. But this is a good start. I think we're fine. I can add to it. Nice base. I mean, it's easy to get to everything I need to get to. I do want to add a cover over this pressure release, because if I am actually making steam, I don't want this thing to pop off and blow steam. Yeah, I mean, just depending on where it's at. So not a big deal, but something to keep in mind. And yeah, and that's that. So oh yeah, I pumped about 175 milliliters in this last few minutes that I was doing this video. So all right, that'll do it for now.